Okay, number 54. In this beautiful figure I have drawn here for you, the battery has negligible internal resistance, which means it's not there. We don't care. And E equals 48 volts. So this is 48 volts. R1 equals R2 equals 4 ohms. So 4 ohms, 4 ohms. And R4 equals 3 ohms. What must the resistance R3 be for the resistor network to dissipate electrical energy at a rate of 295 watts? So the power in this whole thing is going to be 295 watts. What does R3 have to be to make that happen? Okay, so first things first, P equals IV. P is also equal to I squared R. Or P is also equal to V squared over R. And you can get between all of these with Ohm's law, V equals IR. So if we stuff in V equals IR here, that's how we get the I squared R. If we stuff in V over R for I here is how we get the V squared over R. Okay, so the first thing we want to do is find our equivalent resistance. We're going to be going for this one right here because they give us the battery and we have a bunch of resistors. So these two guys right here are in series. So we can take them, smush them together by adding them. So R1 and R2 are each 4 ohms. I'm not going to do that. I'm just going to redraw it. So it's the same thing as if I had an 8 ohm resistor here. Okay. So then this one and this one are in parallel. So we combine those using the reciprocals. So we have 1 over 8 plus 1 over R3 is equal to 1 over REQ. So REQ is 1 over 8 plus unknown. So now I've taken this and smushed it down to look like that, where this resistor is 1 over 8 plus 1 over R, and this one is 3. Now these two guys are in series, so my total resistance is just the sum of those. Okay? So that's my total resistance. So now my power, P equals V squared over R. So it'll be V squared over 1 over 8 plus 1 over R plus 3. So V was equal to 48 volts. Okay. And the power that that's equal to is 295 watts. So now we get to do some fun algebra. So let's switch places with these guys. Actually, no, I'm going to leave these as variables, just so I don't have to carry those around. Okay, so I'm flippy-floppy these. So V squared over P is equal to 1 over 8 plus 1 over R and plus 3. So we're going to subtract 3 over here. So V squared over P minus 3 equals 1 over 8 plus 1 over R. So then we're going to take the reciprocal of both sides. So that's 1 over V squared over P minus 3 is equal to 1 over 8 plus 1 over R. Now I'm going to subtract 1 over 8 over here. Aha, clever use of erasers. And then I'm going to take the reciprocal of that. So my unknown resistor is going to be 1 over V squared over P minus 3 minus 1 over 8 to the minus 1. Alright, so V was 48. So V squared over P, which was 295, minus 3, 1 over that, minus 1 over 8. I'm sorry, you can't see this, can you? Ooh. And then 1 over all of that. So 12.06 ohms. So 12.06 ohms is what my unknown resistor has to be in order to make the power 295 watts.